Okay, good morning, everyone. This is Zay Guan from the Salesforce DX team. I'm the principal software engineer focusing on the performance. So it seems like you are really excited about the Salesforce DX and the Salesforce CLI, right? And you are still with us at the last day of the Dreamforce. So let's just get started and talk about the performance of the Salesforce CLI, especially the Salesforce commands. I will give you some details about how some of those Salesforce CLI commands get implemented over there and what kind of work we have already done to improve the performance of those commands and how you can leverage the work that we have already done to get your job done faster, to improve your performance and productivity. As always, you're going to see these forward-looking statements. You should not just buy the software based on what I said over there, but I will say this is not really impact my talk much over there because most of the things that I'm talking today is already GA'd. So don't worry about that. The performance is the key feature that we think we design and we implement at the day one of the Salesforce DX. So almost all of those features that I'm talking about today has already get into the GA and it has already started to benefit most of our developers. Talking about developers, you may have already known that we are the faster in growing enterprise software developer community. We're going to have 4.3 million developers using the Salesforce platform. And definitely we hope that we'll see the 4.3 million happy face for using this Salesforce platform. And one key important thing about to be happy about using the CLI is the performance, right? Nobody wants to use a powerful but super slow CLI tool to do their job. So the thing that we focus on is the performance, how to get the things done faster. And can anybody guess like what is the CLI commands running super slow over there? Well, I will bet, based on all my experience in the Salesforce Dreamforce, most of the developer or the presenter, when they're doing the presentation or the demo for the Salesforce DX or the CLI, they switch their context, or they will say, some of those commands will take a while, so let's just switch back to my slides and talk about something else. There are two commands hit the highest rank for those kind of like a context switch. One is the Salesforce force Apex test run. The other is about the force source push to move all your metadata from your local source to the scratch org or the org that you're working on. So that's the thing that we're focusing on over there. But you can see the data that we listed right here on the left side is the command that we use the most by count. And the force source push is definitely the number one over there. In the last week, our developers have already used it for over 20,000 times. But talking about the average time execute of those commands, the force auth web login is the number one. It's actually a human interactive command. You need to find it out your DevHub username and a password, and it will open the web browser. You get into that web browser and logged in, and then goes to the Lightning web page and get everything loaded up over there. So that's why it takes a lot of time. But if we count about like how much time totally together spending in our Salesforce CLI, the Apex test run will be a huge chunk of those. So we have some other data that we calculated over there. Based on our information we collected from our production site, 80 to 90% of the CLI usage is focusing on the customer CI and the CD process, the continuous integration and continuous development. And among all of those process, 95% of the time was spending on those two commands. One is for the Apex test run, and the other is for the metadata source push, or you can call it metadata deploy. Depends on you're the old-fashioned metadata API user, or you have already adopted the Salesforce DX thing. So let's just focus on the first one, Apex test run. And I will show you how that goes implemented in our Salesforce DX. When you send a command to say, run my tests, run all the tests in my org, the server will get that request, and it will talk to the database to say, give me all the test information. Let's assume that we only have 5 tests that defined in this org, and the database will just tell the application server saying, I have 5 tests over there, and the application server will create a job for each of those tests and pump them up into a job queue to do it automatically by the job queue. So the job queue is a system resource protection mechanisms that they can schedule the job run of your tests one by one, or probably in some parallel ways. So we have a weird rule defined over there. For any of those orgs, you can run at most 2 tests in parallel at any time. So that rule was defined several years ago, and it majorly focused on 2 things. Number one is, it started with you run several tests, and when you run several tests, the time that's spending on those tests may not so be important. But the second thing will be the more important thing is the test dependencies. Let's assume, like say, you have one task to change your address from address A to address B, but another task to change your address from address A to address C. So if you run those 2 tests at the same time, the result will be unpredictable. So that's why we limit the number of the tests you can run at the same time. We only give them 2 processors to process those tests. When you get a test job 1 and a test job 2 to be processed by those 2 processors, all the other jobs need to wait in the queue to be served until they find out some empty processors over there. So the job is more like this. Once the test job 1 gets finished, it's been put into the test result database, and the test job 3 can go into the processor and get processed, and so on and so forth, until you get all the test job done and all the results saved into the test results, and our application server can notify the user to say, I have already got all the tests executed, and I generate a test report, and you can retrieve the test report from here. So that's the whole thing, how it runs over there. Well, guess what? Do you think that it will be faster or it will be slow? I think it will definitely be slow, right? Because it only allows you to run 2 tests at the same time. And we did collect some information over there. Based on our collection, most of the test runs, we have over 250 test cases that will be run in any of those test executions. That's just an average number. Each test execution only takes about 17 seconds. And the job waiting in the queue will about 390 seconds. That's about 22.7 times that waiting in the queue than the time that you really do the job. So that definitely is a bad user experience, right? Think about this. You go to Starbucks and try to grab a cup of coffee. The waiter just saying, okay, I can make the coffee for you in 1 minute, but you need to wait for another 22 minutes. So most of the time, I'll just walk away, right? What is the reason for those long waiting? I would say it's because we have that limitations over there for running 2 tests at the same time. As I said, it's a rule that we defined several years ago, and it may not be applicable to the current test runs we have right now. It was designed to run several tests at one test execution, but now our users started to use this Salesforce DX to run hundreds or thousands of tests at the same time. So the rule may not apply over there, and how can we change it to give our customers a better user experience? Well, think about this. If you check out when you do the grocery shopping in the supermarket, and there's only 2 cashiers to help you check out, assume you will get a long line over there waiting for the checkout, right? If we get 10 cashiers to help you to check out, maybe the line will be shorter. So that's the way that we do it. We create another job queue, and that job queue, we have 10 servers or processors that can process all of those test cases. And it can allow at most of those 10 test cases running at the same time. But just keep in mind that this number of 10 is configurable, and we have the privilege to change it without any public notification. So don't try to game this system about that. but our goal will never change. We want to give our customer a better user experience, to run their test faster, to get their job done faster. Now, let's see how fast this new job queue running over there. Based on the last 30 days on all our sandbox instances, the old queue that allow at most 2 processors per org, the average waiting time is almost 1400 seconds. For the new queue, we allow 10 processors running at the same time. The average waiting time is less than half a second. Right? It's more like our Dreamforce experience. If you want to get into the keynote, you get a long line over there, and you probably need to wait for 10 minutes or 20 minutes. But if you just want to pick up your badge or do the registration, we have a lot of processors to help you, and you can get things done pretty quickly. So you will feel the powerful of this new job queue. But now the next question is, how can I take advantage of this new job queue? How can I let my test running in the new test queue? In Winter 18 release, we get a new option for attack. Like every test you mark it as add is test. This is a test class, right? Now there's a new option over there saying is parallel equal true. And you can put it over there. It automatically, the system will automatically get your test running over there. Again, this test of the execute 10 tests at the same time is something that configurable. We have the privilege to change it without any public notifications over there. So if we use this is test and is parallel equal to true, apply it to the Dreamhouse. If you haven't noticed about the Dreamhouse yet, if you don't know about what it is a demo application that we use to show how to use the Salesforce CLI, how to use the Salesforce DX, that kind of thing. And it has 37 test methods defined in 8 test classes. If we apply that is parallel equal to true to all the test classes, you will see that the test run time decreased from the 7.6 seconds to 4.5 seconds. But there's only one test failure over there because of the test dependency. Well, easy way to do that is you put that test back into the old queue and get the other 7 tests still running in the more parallel way. And you can get 4.8 seconds execution time. So that is 36.4% of the improvements over there. So the tips right here is just check your test cases and see if they can run in parallel. If you can run them in parallel as much as possible, you will get a better performance over there. It's more like a supermarket checkout line, right? You want to find it out a supermarket with more checkout lines over there, so you can accelerate your job and get your job done faster. Then we have already solved the Apex test run problem. Now let's get into the metadata deploy, or we call it source push. When you send out the source push command to the application server, the server will firstly send it out the request to the database, and the database will return back an ID. And the server will put that ID into the job queue again. Once you have a hammer, every problem is a nail, right? We have the job queue, so everything gets into the job queue. It looks beautiful until you get a bunch of those users using the source push, another bunch of users using the metadata deploy, and we have the second part of the user that using the tooling container deploy over there. So pretty soon, you will find it out, your job queue is just getting longer and longer. And there are 2 complaints about that. Number 1 is everybody get delayed, and they need to wait a long time for their job to be executed. Number 2 is some customers will complain saying, hey, I just want to make a very simple change, maybe the description of my custom object. Why I need to wait in the same queue as those CI and CD job runs, like deploy 1,000 components over there? Why I need to wait in the same queue, right? This is not a new problem at all. In the supermarket, if you get into a really long line, what we should do, add more cashiers over there and open more windows for the checkout. Or if you have somebody just buy several stuff over there, you don't want them to wait for somebody to really buy like 100 stuff. So you open the express lane, and you're saying that if you buy 12 items or less, you can use this express checkout, and then check it out faster. So we do the same thing for our job queue systems. We create 3 queues over there, and we categorize all of those jobs based on their size into different queues, like the larger queue, medium queue, and the small queue. And once we put those over there, the job can definitely run in faster. And let's check out the delay, average delay for each of those job queues. On the larger queue, it's almost 3 minutes. And the medium queue is 1 minute and 10 seconds. For the small queue, it's 37 seconds. Well, it sounds really good, right? But it will only as good as it could be. What if I want to use some IDEs to do some interactive transactions over there? I change my Apex class and I save it, and I go back to my Scratch org and I want to check it out, the results over there. And you will see this spinning wheel over there because it's just waiting for that 37 seconds to be stored or to save everything into the server. That is not a good user experience. How can we do that? Well, we open another processor pool over there to say, for those small jobs, you really don't need to go through the queue, right? Think out of the box. Why we need to wait in the queue? Why not we just do some off-queue processing? That's the rule over there. We get an off-queue processing for those small jobs, and based on that, you get the less than 1 second delay time for your interactive transactions. We just think about it, it's more like in the supermarket as the self-checkout, right? You really don't want to wait for the cashier to help you. You can do the self-checkout. So, how can you get your job to be processed in the off queue or the small queue? Well, if you want to use the small queue, make sure every component source push or the metadata deploy, you have your component count less than 30. If you want to use the off queue processing, you need to be on the Scratch org. You need to get your component count less than 30, and also you cannot run any tasks over there. Again, all of those numbers are just configurable, and we have our privilege to just change it without any public notification, okay? So don't try to game this system, but our rule will never change. We want to give every customer a good user experience. We want to improve the system performance, and you can improve your productivity based on the performance. So the tip right here is, we know we prefer the small, frequent source push or upload. It's just like saying do the grocery shopping. You don't want to do the monthly grocery shopping with hundreds of items over there. You want to do more frequent grocery shopping with small items, and then you can use the self-checkout or the express checkout. If we apply this to Dreamhouse and we cut the whole push, which is including 187 components, into 4 pushes over there, you'll find it out using the old way, it gets to about 56 seconds. If you're using the new way, push small pushes over there, although you push more times, but you can get 49 seconds. So that is the 12% of the improvement of the performance. So the tips is, we prefer the small pushes. We prefer the more frequent small upload over there. And if you can, try to divide your source into small pieces, and you can do better insurance to get you a better performance. So to be performant is actually an option, and now you have the option. Oops, that's it. Thank you. If you have any questions, we can talk offline.